right, here we go. So vertical curve calculations. A couple things we need to know. So essentially to work through a vertical curve, it's the quadratic equation. Straightforward-ish. The quadratic equation is y equals ax squared plus bx plus c. What am I looking for here?
Is that your stationing down at the bottom?
Yes. So what this is here, what we're looking at is the actual page from the lab handout. So another quick equation we need to look at. Let me write that down here. So the quadratic y equals a x squared plus bx plus c. Y is going to equal the elevation of the station we're looking for. So I'm just going to put ELEV. A gets a little bit wonky on us here. X, I guess I ought to specify here first too. X is the distance from the BVC to the station you're solving for. So with that, A is going to be G sub 2 minus G sub 1, that quantity over 2L times x squared plus the B here is going to be G sub 1 times your distance, and the C is the BVC elevation. Any questions so far? Pretty confusing? So our grade coming in is G sub 1. Our grade coming out, G sub 2. What we have here is a PVI station elevation, grade coming in and out, and the length of this particular vertical curve is 700 feet. That is a horizontal distance. So first things we're going to need to calculate, what is the BVC, the beginning of vertical curve, and the EVC, the end of vertical curve, the station and the elevation. So I need to get my handy dandy calculator here. I'm going to calc through this with everybody and let's see how we do. So we have a PVI station of 50 plus 0, 0. We have a vertical curve length. The entire vertical curve is 700 feet. Half of that would be 350 feet, right? So we're 350 feet from the PVI. So to simply solve for the BVC station, you're going to just subtract your 350 from 50 plus 0, 0, which turns out to be anybody? 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 No calculators out? 46 plus 50. Not too hard, right? That's pretty basic. Now, the EVC station, this is a little different from horizontal curves and vertical, the difference with horizontal and vertical curves. When you do have a horizontal curve, we know we use our back tangent, take that distance to get our PC curve, and then we add the arc length. That's not the case with the vertical curve. Here, with the vertical curve, we're going to do the same thing. We're going to add 350 to that. So 50s plus 350 53 plus 00. Everybody with me so far? This is like the easy part here so far. This is the easy stuff. What we need to calculate next would be the BVC and EVC station grades, the elevations at those. Anybody want to take a stab at how we do that? Do we have enough information? Can we do that? Oh, yeah. So if we remember our other small, simple equation here, the old rise over run equals slope. Well, what do we have? Well, we have the slope and we have the run. We need to solve for the rise. So do a little bit of mathematical gymnastics here. We want to solve for the rise. So the run times your slope equals the rise. So if I take, this is 4%. So to get this in an actual, we want to divide that by 100 to get that into an actual number to do this calculation with. 0.04 times 350, our slope times our run, gives us a rise of 14 feet. The rise being the difference in elevation from the PVI to the BVC. And just real quick, if I were to go like this, we know this is 350. We have our 4%. We just found the rise, which is 14 feet. Take that 14 from your PVI elevation, the 798.3, and we get an elevation of 775.30. Nothing too crazy so far. Where is the eraser? All the way down there, I walked past it. Don't want to get too much confusion in here. Okay, once we have the PVC elevation, we need to look at the EVC elevation. Now for this example, this works out very nice because our grade is exactly the same, 4%. Our length is the exact same, 350 feet. So we're going to do the same thing. We're going to get a difference in elevation of 14 feet and subtract that from the PVI elevation. And we get the same elevation. So nothing too crazy here so far. This is pretty simple, pretty basic. We've done a lot of these calculations. This example here works out this way that the BVC and EVC elevations are the same because the grade coming in, the grade going out are the same. If you had different grades, you're going to come up with different elevations for the beginning and end. So what we were to calculate are the elevations at station 47 plus 00, 48 plus 00, 49, 50, 51, and 52 along that vertical curve, which is a parabola. So far, so good. Now, when we start plugging this information into here, I want to change that 4% to our working number, which so I would look at this as positive 0.04 and G2 being negative 0.04. Just dividing it by 100, move the decimal place over 2 places. Boom, boom. So what we have here also, I probably should have started off with or explained as well. We have a positive grade coming in, a negative grade going out. As you can tell by the shape, this is what we would call a, not a sag curve, but a, oh, the name just left my head. What's the opposite of a sag? Crown? Or you'd have a high point? Oh, that could be. Convex could be. That's what would drive me crazy. What's that? That's in our chapter book here. You have 2 different types of curves. Why is that name just completely slipped my brain? Not embarrassing in the least bit. Crest. Crest curve. How silly for me to think that. Sag curve, crest curve. So because we have a positive coming in, negative going out, we're creating a crest curve. Do we have enough information to start solving for elevations of some station? Let's start at station 47 plus 00. I don't want to work through this whole entire curve for this part because I would like to kind of go over and have time to review for the test as well. So maybe we'll do like 2 of these kind of quick-ish. If I was to start writing this out, we're solving for an elevation at station 47 plus 00. G sub 2 minus G sub 1. G sub 2 minus G sub 1 divided by 2 times L. L is your total overall length. Again, X is the distance from the BVC to whatever station you're going to. I know I'm going to probably hoobajoob something up here, so this is where the fun begins. Let's start writing this out here. I'm going to start with elevation is equal to G sub 2 minus G sub 1, negative 0.04 minus 0.04. That quantity divided by 2 times 700. What's our x? What's 74 plus 0? 0 minus 46 plus 50? That's 50 feet, right? So this whole quantity times 50 squared plus g sub 1 times x plus the BVC elevation plus 775.30. Not too bad. Sounds so good so far. I know I'm going to miss a step here or I'm going to do something wrong. This is where I get messed up myself. 0.0 negative 0.04 minus 0.04. Oop. I think there's something to do with this negative numbers messes me up. So I get negative 0.08 divided by 1400 times 50 squared plus. Let me jump this far here. Let's see, 0.04 enter 50 times. Daggone it. I hate when that thing times out on me. I am not computer savvy enough. I tried to change my timeout and I don't know. It's buried in some kind of setting where I have no idea if I'm even allowed to do such a thing. All right, so I have all my numbers here. Let's add it all up. And sorry to get in your way. So if I add all this up, I come up with an elevation being 777 point, and we'll round 16. I hope somebody else is working through that. I did already kind of run through and got answers, and that does check with what I had. That scared me a little. So, how intimidating does that feel? Let's work through one more station. Let's go to 48. And you know what? Actually, I shouldn't have erased everything here. This portion right in here is going to stay the same as you work through this. Your X is going to be the only thing that changes. So let's start over again. Let's go elevation equals negative 0.04 minus 0.04, that quantity divided by 2 times 700, our length. So we went 50 feet. Now we're going to the next station. What's 48 minus 4650? Right, 150. Plus G sub 1, 0.04 times 150 plus, and our BVC elevation stays the same, 775.30. Set down my calculator. So I'm going to work out this whole entire portion here. I get negative 1.28, say 6, plus 0.04 times 150 plus our BVC elevation 775.30. Add all that up. That seems kind of weird. That doesn't sound right. 780.01. Nope, that is what I got too. Okay, so for this, for station 48 plus 00, we would say 780.01. Anybody have any questions on hand calculating elevations through a vertical curve? Again, in my many years of experience out in the field, I never had to hand calculate one of these, calculate the elevations. But I think it's good just to give you guys some exposure to it. So that's all I really want to do for the vertical curve portion here. Does anybody have any questions? Anybody want to go over anything else? Anything at all? All right. Well, we will conclude this portion.